All right, so example 1 for worksheet 2. They give you a data table that has velocity and time. And they ask you certain questions then about this particle. So for the first one there, when time is 0, is the particle moving to the left or to the right? Your particle is going to be moving to the left because the velocity is negative. And then for number 2, is there a time from 0 to 12 when the particle is at rest? Explain your answer. So in this interval right here, the velocity changes from negative to positive, which means it would have to equal 0 somewhere in that interval. So since v of t changes from negative to positive on the interval from 0 to 2, it's intermediate value theorem. So intermediate value theorem says since this function is continuous and it's differentiable on that interval from 0 to 12, that you have to have a value in there since the velocity changes from a negative to a positive. There's a place where that velocity then would have to equal 0. All right, the next part asks about the velocity. So what's v of t going to be? Actually, it's acceleration v prime of t, and explain the meaning of v prime of t. So v prime of t, if we find that value, that's going to be change in the velocity divided by change in the time. At time is t. We don't have a point for time is t, but we have a value for larger and smaller than that. So if I do my change in my velocity, which would be 5 minus 7, divided by 12 minus 8, that's going to give me negative 2 over 4, which is negative 1/2. We need to include the units for it, so it would be meters per minute squared. And then it says explain what that means. That's going to be our average acceleration on the interval from 8 to 12. So from when time is 8 to 12. So that's part 3. And then number 4 asks about the acceleration of the particle. Is there guaranteed to be a time c in that interval where the acceleration is going to be 0? So that's talking about your Rolle's theorem actually is what ends up happening for this one. So if you look at this one value up here when time is 6 and time is 12, the outcomes are the same values. So Rolle's theorem and mean value theorem are kind of the same thing. We're saying you have a continuous function that's differentiable. If there are 2 y values that are equal, if I connect those 2 y values, and then since it's a continuous and differentiable function, there's got to be a c value somewhere in between there, where the slope for that tangent line is also 0. Mean value theorem, the slopes could be any value, but this one is talking about acceleration equal to 0. So my average acceleration between 6 and 12 is going to be 0. That means this slope would be 0, so we got to come up with this c value in between there. So my acceleration would be the change in the velocity divided by change in the time. If I find that acceleration at, let's do that for that value in between there, we'll just call it t. So my change in velocity would be 12 minus 6 over my, 5 minus 5. Oops. Weird things happen. Here we go. So it would be my change in my velocity, which would be 5 minus 5, over my change in time, which is 12 minus 6, so you get 0 over 6, which is 0. And since this function, I'm just going to put it up top here since I can't put it. Since the function, which is continuous, and it's also differentiable on this interval from 0 to 12. Rolle's theorem guarantees a value for the time when A of t is equal to 0. All right, so that's the first one then.